Hello, today we're going to be talking about modulation effects like chorus, vibrato, phaser, flanger, etc. So let's jump into it. Okay, so in Ableton, these modulation effects are found in the pitch and modulations folder here, namely these two guys right here, the chorus ensemble and phaser flanger ones. These things are called modulation effects because, as you'll learn, within the effect, they're all using LFOs in one way or another to create the outcome that we're hearing. So within this chorus ensemble device, there's this tab here called Vibrato. So when I click on that, you can see the diagram changes from multiple lines to a single line. And this represents an LFO, which is modulating the pitch to go up and down. And that's what this diagram is trying to convey here. So you can hear this sound here. When I turn this off, sounds like this. It's like a synth pad. And then when I turn that on, you can really hear that pitch being modulated up and down, right? So this is a vibrato, a really simple effect. It's just pitch modulation. That's it. We can change the amount here for the amount of pitch modulation, and then we can change the rate as well. So before we really jump into this, I just want to touch on this thing. I just want to remind us about how stereo sounds are made. So the definition of a stereo sound is something that is different in the left-hand side to the right-hand side. So music has two channels, a left and a right. And if there's a slight difference in the left and the right, then it's going to sound really wide to us. So if I duplicate this synth pad here and pan this one over to the left and pan this one over to the right and hit play, we're not going to hear any difference at all. It's going to be the exact same because we haven't made any changes from the left and the right hand side. But if I was to cut this out and do something like this, let's just stretch it out a little bit. Now we're creating some differences, so it's going to appear wide to us. See the huge difference between this and this? So as soon as you introduce some sort of difference between the left and the right-hand side, we get a really wide stereo image. So the general gist of what happens with most modulation effects is we're duplicating the sound and then we're changing one of them or modulating one of them, and then we're combining them back together and we create this interesting result. Okay, so the next thing we're going to be talking about is chorus. And if I put it onto this classic mode here and hit play, let's have a listen to what the chorus sounds like. Chorus has this really lush sound to it and is often used to create a stereo effect. So this is our stereo spectrum here. If I turn off the chorus, let's have a look at this. You can see that it's mono, there's no stereo information. And if I turn it on, you can see that stereo effect that's been created. So how do we create this effect? It's kind of like using a vibrato. We're creating a duplicate copy of the sound. So let's just hit Command D here. So we're creating a duplicate here. We're going to leave one of them dry and we're going to modulate the pitch of the other one up and down, just like the vibrato did. But chorus is slightly different to vibrato because instead of modulating the pitch, we're going to be modulating the time of a delay unit. So delay time modulation is another form of pitch modulation. So let me show you this. I've got this delay device here. I've just put it on only this track. And what I'm going to do is turn the dry wet all the way up and turn the feedback all the way down. And then I'm going to turn it onto time mode over here. And check out what happens when I move this knob around. If I hit play. So you can hear that repitching effect that's being created by moving this knob around, right? So if we were to go get an LFO and map this LFO to this delay time, and I'm just going to change the maximum amount, turn it down so it's just a little bit of delay time modulation. I'm also going to reduce the rate so it's a really slowly moving LFO. So you can hear that the pitch is being modulated to move around similarly to the effect that we had by using the vibrato over here. So if I modulate one of these guys and mix that back in with the dry sound, this is creating this lush chorus effect. And this is represented in this chorus diagram here as well. We've got two lines. The audio stream has been duplicated, and then we're essentially just wobbling the pitch of one of them and putting them back together and creating this thickened sound here. Right? As I turn the amount and rate up, you can really hear that pitch modulation more evident, right? If I go to ensemble now, it's essentially doing the exact same thing, but it's adding another duplicate and it's evenly spacing out the modulation of these audio streams to make it sound a little bit more full and smooth. You can think of it similar to if you have 3 voices singing in a choir as opposed to if you have 6 voices. The latter is going to sound more lush and full, and this is the same with chorus versus the ensemble effect. By the way, if you're new to music production, we have this thing called the EDM Starter Kit. It's pretty much just a pack with a whole bunch of presets and samples to get you started, so I'll leave a link to it in the description below. Alright, so moving on to the phaser and flanger device. First of all, I'm going to be talking about flanger. Flanger in many ways is similar to chorus, but with some slight differences that really drastically change what it sounds like. So let's first have a listen to this. I've got this bass line here with some flanger on it. That's that classic sort of metallic sweeping effect that flanger generally has on our sounds. So how this is created is similar to the last one. We duplicate the audio. Also similar to chorus, an LFO is modulating the time, just like we had before. So I'm going to map this and modulate the time. But this time we're modulating at a very small amount. We're doing it a lot slower, and we don't have any pitch modulation. So what gives chorus its characteristic sound is that vibrato pitching effect, but in flanger we don't have that. So I'm going to turn it on to fade mode instead of repitch mode here. I'm going to put it on fade, put this dry wet all the way up, and I'm also going to reduce the rate. So it's a really slow moving LFO, and let's have a listen to this. So you can hear as the LFO moves up and down, we're getting that flangering effect. So just to explain this a little bit further, if I zoom into the waveform here, you can see that both of these waveforms are exactly the same, right? And if I was to drag this one slightly over, that's essentially what we're doing when we're using this delay device, right? So as the LFO moves around, it's going to be delaying it more, and then it's going to be delaying it less over here, and then it's going to be delaying it more. So it's going to be moving around underneath the top one. And what happens when you do that is these peaks will line up sometimes, and that is called phase alignment. So these peaks and these troughs, they align with each other and they boost each other. But other times, the peaks of this one is going to align with the troughs of this one, and this is called phase cancelling. So when they're like this, the frequencies are going to be cancelling each other out, and that's why moving this back and forth really slowly is going to create this sort of metallic phase cancellation effect. So just to recap on that, by modulating the delay time down here really slowly and in small amounts, we're creating a more metallic phase cancellation effect that we know to be flanger. So the last one here is phaser. This is what it sounds like on these pads here. This one is similar to flanger, but it's a lot smoother and less intense. And this is really good for giving pads and synths a bit of movement. Now, phaser is a little bit different because it uses these things called all-pass filters. Now, an all-pass filter is named as it is because it's not affecting the volume or the gain of the sound, the amplitude, but it's only changing the phase relationship of particular frequencies. So just like in the flanger, when we delay one of the signals, we're creating these differences in phase, right? But an all-pass filter is different because it can change the phase in the low frequencies different to the high frequencies. So these little dots that are moving around and creating the phasing effect are multiple different all-pass filters. The amount of notches here is the amount of all-pass filters that we're using, and the more of these we have, the more intense the effect, right? So the less of these. So we can actually hear the phase differences sweeping around when we have one all-pass filter. and you can hear it being swept through the frequency spectrum. So we're essentially just modulating how the phase of the sound works. We're flipping it and then we're flipping it back and we're sweeping that all throughout the frequency spectrum. It's one of my favorite effects. It has this really sort of sci-fi spacey tone about it, which I really, really like. So phases are a little bit more complicated. So the explanation there was just a little bit more technical, but in the end, we're just delaying the signal slightly differently to how we're doing it in a flanger or a chorus. So breaking down all the individual pieces, these are actually all quite similar effects, but it's the slight differences that actually make a big impact on the sound. You don't necessarily need to know how these things work in order to use them well, but it is nice to have a little bit more knowledge about how things work under the hood. So if you've enjoyed the video, remember to like and subscribe to the channel. Otherwise, thanks for watching, stay safe, and I'll see you in the next one.